Okay. Good afternoon, everyone. So this is our third class for OCP Analytics, SPSS and Minitab class. So we're going to continue from where we stopped. I believe so far we've been making progress. We've learned how to code, recode into the same variable, recode into different variables. We've also learned how to do descriptive statistics. I taught you guys the four different methods four different ways we can use, using frequency, using descriptive, using explore, and also using case summary. Then we know that explore and case summary, when do we use it? If we know that we have a group, we want to group, if we're interested in looking for the descriptive statistics of a variable, but we want to also group it, then we use either explore or case summary. Now it depends on how you want your result and maybe the things you want. Sometimes what you see in case summary, you may not see it in explore. And what you will see in explore, you may not see it in case summary. So today we'll continue from where we stopped. Where I'm staying is very hot, so I'm not putting on a shirt. That's why I'm not showing my face today. It's very hot, so that's why my video is not showing. So I want to share my screen now. If you have any question, we know the rule. You raise your hand up. As if you have any question, you raise your hand up. Then also, if I'm sharing my screen and you're not seeing my screen. If I'm sharing my screen and you're not seeing my screen, always tell me. Emmanuel, do you have anything?
Where can I raise my hand up?
Go to reaction. Are you seeing reaction? Go to reaction, you will see raise hands. I've done my, look at my name, you will see my hand is raised, correct? So that's how to raise your hand. Okay, so you can take your hand down. Go do the same thing and take your hand down. Correct. So let's continue. So if whenever you have a question, you can stop me at any time, just raise your hand. So I want to share my screen now. So I believe you all can see my screen, right?
Yes.
Okay, so
yes, sir.
Okay. So let's use the data we use in our last class. I thought I saved it. Correct. Okay. So we have this data so that we can use it. So we are done with descriptive. Okay. Also, we are done with the different graphical methods. So we are done with this. So let's finish with descriptive. The only thing we need to learn here is crosstab. So let's learn crosstab. So let me explain crosstab. Then I will not explain PP plot and QQ plot now. Maybe later I will explain that. But we'll learn crosstab, then we'll move to something else. Now I will tell you why I'm not going to explain this now. Okay. Today we'll also touch. We'll try to touch Minitab. So let me explain what we use crosstab for. Now, when you want to do an analysis, you are like a doctor. You have a patient will meet you and tell you their symptoms, what they want, what they are suffering from, the challenge, the problem. They don't know what will cure it. That is why they are meeting a doctor. Then the doctor will recommend the appropriate method or the appropriate drug for that particular ailment. So that's how it is with data analysis. People come with their challenges, they come with their problem. They don't know what to do. They don't even know the statistical method to use. They are not statisticians, they are not analysts. So they come with their problem and they tell you their problem. They tell you what they want. You'll be the one to recommend the appropriate statistical tool to use to achieve the result. Now, if you are not familiar with different tools, that will be a big challenge. That will be a big problem. So you have to be familiar with different mechanisms, different tools in statistics. So far now we'll start rating different tools. And when I start teaching you the different tools, I will tell you the uses of the different tools, when to use them. So it's very simple. So today, like I said, we're going to start with crosstab. Under crosstab, what we do here is chi-square test. Now, for chi-square test, we have two types of chi-square tests we're going to talk about. That doesn't mean these are the only two types. They have more than two types, but for this class, we'll talk about two types. The first one is about test for equality, while the second one is test for association. The second one that is test for association is also called test for independence. Forget about all I'm saying. I will explain it in detail. So let me start with the test for association or test for independence. Now, if I have two variables, so let's say I have gender and I have performance in a course. And after assessing two different classes, I discovered that the females, they perform better than males. I can decide to carry out a test. Is it that gender has something to do with the performance of students? Is it that there is an association between gender and the performance of students? So that's the problem. So I want to carry out the test. So someone has been having this issue, has been noticing that it's like females, they only perform better. But you know, in statistics, you don't make a statement without carrying out your experiment, without carrying out your analysis. You don't make such statement. You can't just come boldly and say females perform better. So you have to prove it statistically. So you prove it scientifically also. So that's what I mean. So you have been noticing that maybe females are performing better. So you have to carry out a test. So they meet you as a statistician. I want to know if there's any association between gender and the performance of students. That's the challenge. So, like I told you, the person meeting you will not know the tool to use, but you know that for such case, what you use is chi-square test for association. So, or chi-square test for independence. So what do we use this for? We use this to test if two variables have any association between them. If two variables are independent of each other. If two variables are dependent on each other. I've said three things. First, we use it to, all of them, they are the same thing, just different ways of saying it. If two variables have any association among themselves, if two variables are independent of each other, or if two variables are dependent on each other. So that's when we use chi-square test for association. So now look at this. Now we have chemistry score and we have gender. Remember, this gender was coded. I've taught you how to code it, and this is how to check if you use this to check if your coding is correct. So can we carry out a statistical test to know if the performance of students in chemistry has anything to do with their if the performance of students, the grade, has anything to do with their gender? Okay, let's start with something simple before we do this. So I want us to group these grades to create a new variable where we'll group this grade to pass and fail. So let's practice what we've learned before. So we are going to do from A to C pass, then from D to F fail. So what are we going to do? We're going to use recode into different variables that I've taught you guys. So I want to recode grade. So I'll put it as remark. There is no underscore. So because there's no underscore, I don't need to write anything at label. I'll click change. O to new. Remember, I will click, since I want string, I will click string. So A will be pass. Or let me code it. A will be 0. B will be 0. And C will also be 0. So I can remove since I'm coding it, I can remove the output as string. I'm coding it. A will be 0. B is 0. And C is 0. D to be 1. 0 means pass. E to be 1. Why I'm doing this, I just want two groups. So I want to start explaining chi-square using two groups before I go to more than two groups. I don't want to start with 4 or 6 groups. So continue. Okay. So I have something like this. So I can come to remark. Okay, let me teach you guys something. Look, under way of going to variable view and data view. If I want to go to variable view, I can click this. On that way to go to variable view, I will double click this up part, any of them. I will double click it. It will take me to variable view. If I want to go back to data view, I can come down and click data view. Or I can click any of these numbers, double click it, double click any of the numbers. So you double click here, double click here. So double click here. So I'll come to value and tell 0 means pass. Someone wants to join. Okay, nobody. So 0 means pass and 1 means fail. Okay. So let me check if what I can change the decimal to 0. Let me check if what correct. So what I coded is correct. It's already passed and failed. So if I want to do the chi-square, I want to know if the performance of the remark of the student has anything to do with the agenda. So I come to analyze, descriptive, cross tab. So for row, remember we have two variables. The two variables we have here a grade, sorry, gender. Remember I told you how to, you can click and drop or you use the arrow. You can't double click now. Why can't you double click? You have more than 4 dialog boxes, more than 2 dialog boxes. So you cannot double click. If you double click, it will not work. So you drag and remark, you can click and or you click and use the arrow. Then the next thing you do is you come to statistics and click chi-square. Forget about this other things. Click only chi-square. You continue. If you want to see the calculations that brought the result, you can click this. If you don't want to see it, you leave it. So it depends on what you want. If you still want to see all this, you click it. But if you don't want to see it, you leave it. If you want it to come out with a bar chart, you click it. If you don't want it, you leave it. But what is very important here is the chi-square. Because I clicked expected, that's why this expected came out. Those in statistics, I believe they've taught you the formula for chi-square. I think is so we know the formula. I think summation. Shidera, what's the formula? Summation what? Observed minus expected all square divided by expected, right? Shidera. Okay. So this is the result. Now I talk about that okay, let me show you what to do in this case before I explain what I was about to explain. We don't need all these things, so I will delete them. We don't need all of them, they are nonsense. I will delete them. That doesn't mean they are not, they may, I think either maybe they use all those things to calculate, I don't know. But for now, based on our interpretation, we don't need them. So you saw I deleted them. It also brought, because I asked SPSS to give me a bar chart, bar chart. You can edit your bar chart by double clicking. When you double click, you change the color and do anything you want to do with it. So now let me show you guys how to interpret. Now, don't just copy everything. You don't copy this. This is don't copy this. You don't copy this. So you don't copy everything you see in SPSS. Okay, let me open a new sheet. So when you do analysis like this, I can copy these three. One, I'll hold my control and select what I want. I want this also. I'm still holding my control and I want this. Then I will do Control C. I was holding my control while clicking it. Then I will paste it. Normally, I like changing this to Times New Roman 12. I like changing it before I start typing. So I paste. You then interpret this. Now I discovered that I asked you guys to do frequency distribution. Most of you didn't interpret it. You don't just paste table most times. Me, I don't like, okay, also, I don't like my table to be like this. This is how I arrange my table. I remove all the border first. It's your choice. So I'm not saying you should follow me. This is how I arrange my table. I can do something like this. I come to border. I add bottom. I add top. I don't like too many lines in my work. I can do something like this. Top. Top. So this is how I arrange my work. No. Bottom. Bottom. So I can do something like this. Okay, this I can. Top. Correct. So this is how I will arrange my table. I don't know, it's your choice. Let me show you what we had before. Copy. So let me show you what we had before. This is what we had before. I don't know how the one you prefer. Me, I prefer this to this. I don't use this. You can never see if I want to do a good work for you, except I just want to send it. I can't use this. I don't ever use it. It's your choice. That doesn't mean it's bad. Just your doesn't look good. That's my own perspective. So this is what I would do. I will also do the same thing to this. First, I remove the border. No border. I will align this. Bottom, top, top. Then I can extend this. So another way you can align this and click option. Sometimes I do this. Okay, well, let's continue. So the next is to interpret. So you have to interpret this. Maybe you write a brief. Just write the way you want to interpret, your choice. I can say the 2x2 contingency table for gender and remarks are given. Sometimes I can label the table 1 are given in table 1. You can continue writing or you come to this place and continue. You can say the number of students that passed and failed. Okay, that passed for male is 386 with an expected frequency of 397.5, while those that failed for male is 170 with an expected frequency of 158.5. Have you seen how I've been able to interpret all this? No, what am I doing? I've been able to interpret all this. So that's what you have to learn how to interpret. So you also do the same thing for female. You do the same thing for female, but I'm going to stop here. So I believe you've gotten what I'm trying to explain. So you give a detailed interpretation of your work. You don't just copy a table and paste. That's very wrong. So you have to interpret at least say something about it. You may not write it the way I'm writing it. This is my own choice. You write it your own way, but at least say something. So after doing that, like I said, you can just write the 2 by 2 contingency table for Gen and H table 1. You can then copy from this and paste here. And come from the table, you can see, so your choice. So I can continue. The observed and expected. This is my choice. Like interpretation doesn't have any fixed pattern, frequencies, but just ensure you give a detailed explanation. We are used to calculate the chi-square test statistic, and also the probability of the chi-square. I'm trying to interpret the next table, table 2. Remember, I called this table 1. So because I called it table 1, you come to this place and write table 1. Depends on what you want, like I said, because I called it table 1, so I have to reference that. Anybody that looks at it will know the table I'm referring to. The observed and expected are used to calculate the chi-square test statistic and also the probability of the chi-square test statistic as given in table 2. Then I'll come to this and put table 2. You can you decide to continue writing here, or you come to below the table to continue writing, your choice. So okay, let me come here. Now you can decide to state your hypothesis, your choice. You can decide to state the hypothesis for the test is, or you just write it as a statement. The test statistic, I can continue calling it chi-square, or I just call it test statistic, since they already know the test statistic I'm talking about. Was used to test the null hypothesis that there is no association between gender and the students' remark in the course. Another way of saying, so the null hypothesis is always there is no association. Another way of saying this is that they are independent, no dependency. So I explained it using 3 ways: association, independency, dependency. So no association means they are independent. It means no dependency against the alternative hypothesis that there is an association. This is not the only way to write it. Now, sometimes when I'm doing analysis for people, for companies, for individuals, I can write it the way they taught you in school, H naught. I can just, from this place, what I will do is, the hypothesis for this test are given below. Then I will write H naught. There is no association between these. Then H1. Then I'll put my alpha. Sometimes I can decide not to write it that way and just write it like a sentence, the way I'm doing now. Your choice. The 0.05 level of significance will be used to test the hypothesis. So now, next thing I can talk about my decision rule. The null hypothesis is rejected if the probability, okay, I can, this place I wrote probability of the chi-square test statistic, I can just write it as p-value, yeah, put brackets, p-value. So anytime I write p-value, they will know what I mean by p-value. What am I doing? P-value. So if the p-value, so now I don't need to write the probability again. I just know that I can write p-value. Everyone will understand. It's less than 0.05. Always align your work. Try to look okay. So one thing about as an analyst, always give people a good job. Are you seeing that I'm giving a detailed interpretation of this work? You give people a good job so that anyone that reads it, whether the person is in statistics or not, the person should understand what you are trying to say. So I've told the person what I will use to make my decision, stating my decision rule. I'm following the steps, those I tested my hypothesis. I'm following the steps I taught you guys. I've stated my hypothesis, I've stated my level of significance, I've stated my decision rule, I've stated my test statistics. So now I want to state my decision and conclusion. I can come down and do that. So the null hypothesis is not rejected. Since the p-value, I can use is less than 0.0, is less than the level. Let me spell it. Your choice. Zero 0.05. And we conclude that there is no association between student remark. I can copy this and paste here. Oh yeah, so I've seen your hand. I'm coming. The null hypothesis is not rejected since p-value is less than the level of significance, and we conclude that there is no association between gender and the student's remark in the course. I don't need to end my conclusion with a 0.05 level of significance because that's why I spelled it here already. So I don't need to write it again. Okay, Oyema, you can ask your question.
Where is the p-value?
Okay. That's a good question. That's a good question. OCP analytics, new folder, chi-square. SPSS. Okay, you asked it. Look at the p-value here. So that's a nice question. I'm supposed to put the value here also. That's a good question. Thank you for that. 104. So this is the p-value. Now, if you watch where this thing is not arranged, so you can also align this thing. You can align. I don't understand this thing I'm using. Don't really understand it. I'm supposed to see formats here. I don't understand this thing I'm using. I'm supposed to see formats. So I think it's the word I'm using. I have to go and change it. But if you see it in yours, you will see formats. Then change it. It will be better. But you go to layout and click this. Align it to where, or anyone you like, but align it to where your work should be always arranged. This one, if it's not arranged, you click, you align it. So ensure you arrange your work. Your work should never be scattered. That's what makes you a good analyst. So I've been able to see, I've done a complete work on. See, and people used to meet me to do work on chi-square. Let me just show you guys few works I've done. See, or this one paid me to do work on chi-square, another work on chi-square, another work on chi-square. See, people can meet you to do work. It may look simple, but they don't know how to do it. So because they don't know how to do it, it's no longer simple. Okay, you can also explain this bar chart. So you give a brief description. So if I want to explain this bar chart, I can take this bar chart up to this place. Since I know that the bar chart is just trying to give us a pictorial representation of what is here. So I can take this bar chart if I want. I can take it and paste here. Then what I can write here is I think it's observed frequency, yes. The observed frequency are shown graphically using a bar chart using the bar chart in figure 1. So that I'm trying to avoid giving another explanation for it. So I'm just trying to tell them what I explained here. You still the same thing for the bar chart. But just the difference is that it's just a pictorial or a graphical representation of what is there. So that's what I've successfully done. But assuming there was nothing like this, then I have to write an explanation like this. The number of these. So you try to give, or just look for a way to interpret your work, your choice. So since I figure one thing you should know as an analyst, table is written up. Like look at what I did. But you don't write figure up like this. You don't write figure 1. No, rather you come to the bottom below it and put figure 1. Very important. You can call it a bar chart. A bar chart of the observed frequencies. If you want to reduce the size of the bar chart, you click and reduce it. So look at that. Remember, I take note of this, what I said now. If you want to label a table, you write it at the top. Or if it is a graph figure, it should be at the bottom. Don't ever forget that. And whenever you are doing working on anything, we are done with chi-square. Any question? Someone has left us. Who left us? Okay, Chidera has left us. Any question? Okay, Chidera is back. Chidera, is it network? Chidera.
Yes.
Is it network that is stopping you?
Yes.
Sorry about that. So we are done. Any question? So no question. Oh, that means I've explained it well. So we are done with chi-square. It's very simple. I see now this work is explained. Everything is explained. So let's go back to our. So subsequently, I don't think I will be giving detailed explanation like this. I will explain it in words, expecting you guys to put it in your own words. I will not be writing it like this. So I just want to show everyone how to give, how to interpret your analysis. You give a detailed interpretation of your work. So subsequently, I may not be writing things like this again. I will expect that you already know it and you do it. But I will always say the interpretation. I will say say everything. So let's go back to this. So let's try another chi-square test. What we did now is a 2x2 contingency table. So why is it a 2x2 contingency table? It's a 2x2 contingency table because the first variable has 2 levels and the second variable remark has 2 levels. If this has more than 2 levels, it's no longer a 2x2 contingency table. Currently is a 2x2 contingency table. Up Nepal! So let's continue. Chidera has gone again. So I will download the video. Okay, so let's try another example before we continue. So I want to try. Okay, I want to ask you guys a question. Have you noticed anything? Can you unmute yourself? Both of you, can you unmute yourself? Onyema, are you with us? Okay. Have you noticed that I avoided using students course and chemistry. Do you know why?
No.
Okay. We are talking about chi-square. Chi-square works with frequency. You discover that when I taught you guys frequency, I also avoided data like this. I look at what we did frequency for this. We can do frequency for this. We can do frequency for this. Doing frequency for this is not proper. So because chi-square works with frequency, so most times we work with what we can count. What we can count. Are you following?
Okay.
We can count the number of A's. We can count the number of F's. If you start counting this now, let me show you what I mean now. If you do frequency for one of, let's say, chemistry, look at what you will get. Look at how the table will be. If you want to use it for chi-square, how many what it will be? How many contingency table? Up to 50. Are you following me? It will be now 20 by 2. So most times they don't really use numeric values for it. So what they use is you can mute yourself now. What they use is categorical, string, qualitative variables. So that being said, let's try another example. So now let's try grades, and remember we recoded grade to remark. The reason is because I wanted to start with a 2 by 2 contingency table. So let's try grade and gender. So that means I'm trying to say, is it that gender has something to do with the grade of the student? Mr. B is saying there's nothing like that, whether you are a male, whether you are a female. So based on what, based on this now, based on this, it means that gender has nothing to do with the performance of students. That's what the conclusion we arrived at. So we're trying to tell the lecturer to stop thinking what he's thinking, that females are not more intelligent than the males. Like, should stop thinking that. So that's what we are. So another person is trying to make a claim that grade has something to do with gender. Like I said, as an analyst, you don't make statement without facts. You don't make statement without carrying out a scientific method on it. So there must be a scientific method before you can make such statements. So whenever you are done, you click reset to start all over. So you move. We are talking about grades. Okay, let me put grade, yeah. Anywhere you like, you can put it, doesn't matter. And gender. Statistics. This is the important one, the one that is very important. Cells. You can click this if you want, but maybe let's just click expected and see the expected. Continue. Let's give me a bar chart. Okay. This is now it's not a 2 by 2 contingency table. It's what? 6 by 2 contingency table. Remember what I did? In this case now, we'll click this. I will highlight this and delete. So you can interpret this now. Interpret. If I want to interpret this, I will say from table 1 below, or from table 1, or the student that have grade A, or the male student that have grade A, or I can say 223 students, or 223 male students have grade A with expected frequency of 235.7. 82 male students have grade B with expected frequency of 77.8. 81 male students have grade C with expected frequency of 84. So that's how I will continue interpreting. Then when I say while 90 students failed the course with an expected frequency of 85.1. Then I can go to female and start with similarly or contrarily, anyone that you want, depends on the situation. So I can say similarly, 201 female students had grade A. Another person can say, no, I don't want to take all the males first before going to female. Let me be taking male and female first, like for grade A. So you can decide to say 223 male had grade A with expected frequency of 235.7, while A with expected frequency of 188.3. So if you watch, I'm interpreting it in another way. I want to, before I started with finish everything about male before you go to female. But what I'm doing now is finish everything about grade A. So that means I will consider both male and female for grade A. both male and female for grade B. So you keep on doing that. So the same thing. In this case, too, we are not going to reject. We are not going to reject the null hypothesis also. Why? Because the p-value is still greater than 0.05. So we are not going to reject the null hypothesis. So I think we are done with chi-square test for association. So we can go to something else now. So let's try the last one, chi-square test for equality. Chi-square test for equality. Now, if you have, remember I told you chi-square now, what we are dealing with, chi-square works with frequency. Now, if you have only one variable, let's say we have gender. Okay, let me explain something in statistics. Now, if Santos and Emmanuel both of them write an exam, and Santos scores 52, Emmanuel scores 50, you can't say that there is a difference in their score, because even though there's a difference, that difference may not be significant. So that's what we mean by in statistics. Sometimes two values may not really be equal. They don't really look equal, but the difference may not be significant. I mean, the difference is not significant. That's what they mean. So when you look at that's why we don't just look at two values and say they are different. No, you have to check if, though they are different, the difference, is it significant or not? Does it really do anything? Does it really change anything? Does it really add anything to it? Example now, if you score 50, I score 52. Hope you know that both of us, we are going to get grade C. So it means the difference of 2 has nothing. It didn't contribute anything to you. It's not significant. You score 58, I score 52. We are still going to get C. It's not significant. So that's why we're saying statistics, sometimes the values may not be the same, but you have to check if truly they are significant. Now, I can decide to say, I don't like this, my class I'm teaching. Let me do something first. Let me check the frequency before I make my statement. Gender. I'm going to the second type of chi-square. Okay, let's say I'm the kind of man that likes teaching female. I like girls a lot, and I like seeing females. So they now give me a class to teach, and I'm not so happy. I said I don't like this class. They say why? So why will the class they have more males than females? Why will you give me a class that have more males than females? I want a class that have more females than males, or a class that they are equal. Or let me say a class that they are equal. Why will you give me a class that have more males than females? And someone may say, no, both of the class, no, that the alternative hypothesis now. I'm making a claim. What's my claim? I'm making a claim that the males are more than females. Why the other person is saying, no, that male and female, they are equal. So you have to carry out the test to check, even though they are not equal, is it significant or not? Even though they are not equal, is it significant or not? Now, because we only have one variable, we are going to use chi-square test for equality. Chi-square test for equality. This is where you see it. You go to analyze non-parametric legacy. Are we seeing it? So let me just keep it here so everyone will see it. You go to analyze to check if the frequency among the levels of that variable. When I talk about levels for gender, the levels are male and female. So you want to check if the levels, they have equal frequency. One variable, different levels. You want to check if all the levels have equal frequency. What will you do? You go to analyze, you go to non-parametric test, you go to legacy dialog, and you go to chi-square. Then you move your Shidera is having network issue. It should be going to a good place, a place that has network now for the class. Maybe I will talk to him later. So we'll move gender to this place. Then let me see. there is nothing else to click. If there is nothing else to click, so I can click OK. So the only thing is just to move your gender and click OK. So this is the result. This is my observed and expected. This is my chi-square. This is my p-value, asymptotic sig. That's my p-value. So in this case, the same thing. Remember, I told you for test of assertion, the H is always no. Okay, for this, we are talking about equality now. Chi-square test for equality. So the null hypothesis in this case is that they are equal. Null hypothesis is they are equal. So it means the number of males equal to number of females. They are equal. They have equal frequencies. Why the alternative hypothesis is that they don't have equal frequencies, or the male and females don't have equal frequencies. So the decision rule always is that you reject your null hypothesis when your p-value is less than 0.05. And in this case, we are going to reject the null hypothesis. Hypothesis is because the p-value, which is 0.00, is less than our level of significance. So as I'm rejecting the null hypothesis, it means they are not equal. So it means what the man has been saying, there is truth in his statement. He's saying that this class they give to him, they have more males than females. So that means since we know that we don't want such, we can decide to take that class from him and give him another class, or look for a way to take some of the males in that class to another class. Because the test has proven that yes, there is a difference, and that difference is significant. Like I told you, the difference may not be significant, but in this case, the difference is significant. Any question? Santos, any question? Santos, are you still there?
Yes, sir. I'm here, sir.
Okay. Emmanuel, are you there?
Yes, sir. Yes, sir.
Okay. Santos,
Yes, sir.
are you still at Tiagua?
Yes, sir. But there's no light here, sir.
Okay, no lights. Okay. Okay, later we'll talk more.
Okay, sir.
Okay, let's continue. So we can decide to do the same test with someone is saying, let me check the pass and fail reset. So someone is saying the number of students that pass and number of students that fail, they are not the same. So you can carry out the test, analyze, non-parametric, legacy, chi-square, reset, remark. The null hypothesis is that pass and fail are equal. Alternative is that they are not equal, or then we are rejecting the null hypothesis. So it means they are not equal. Now we've learned chi-square test for association. We use it when we have two variables and we are talking about association, independency, or dependency. We also learned chi-square test for equality, and we use it to test for equal frequencies or not. We only have one variable, so the one variable can have multiple levels. So we check if the frequencies are distributed evenly, equally. So that's what we do. So like I told you, someone will come with a challenge. You'll be the one to recommend the appropriate tool to use. But let me see if I have a work here. I can't remember the guy's name. Okay, I would have shown you a work I did. So since I can't remember, we'll have to continue. Okay, let's continue. Whenever I remember, I'll come back. So no question, so we can move further. Now let me differentiate between chi-square and correlation before we continue. In correlation, we are talking about relationship. How strong is the relationship? How strong is the relationship? In chi-square, we are trying to check if there is any association. We are not checking, we are not testing for the strength of the association. We are not testing for the strength of the dependency. We are not testing for the strength of the independency. Rather, we are just checking if truly there is an association, independency, or dependency. In correlation, we are testing for the strength of the relationship between two variables. Yes, two variables may have a relationship. Take the keyword relationship for correlation, association, dependency, independency for chi-square. Though two variables may be correlated, may have a relationship. They have relationship. That relationship may not be strong. It means that after 2 days or 1 week, they will serve themselves to breakfast. So that's what we mean by the strength of relationship. But when the strength is very strong, it means that they will last for long. So I've been able to differentiate, but we are not treating correlation now, just to explain it. So if you watch, I didn't give a detailed interpretation of chi-square test for equality because I'm assuming I've done this, and because I've done this, you can also follow the same pattern. Most times when people give me work, I just do, okay, let's leave that. But you just follow the same pattern and give them the good and complete analysis. Chidera is back. Chidera, is like you're having a network issue. Sorry about that. Eh? Okay, sorry about that. So let's continue. So, okay, you can ask your question. I've seen your hand. Ask your question.
So if someone bring analysis for you to do, are you the one?
Eh?
Are you the one to decide what to use for the analysis?
Yes, that's what I started with. If they don't know what to use,
Okay.
you get. They don't know what to use. They are just like they have a problem. Like when you go to the hospital, you have headache, but you don't know the drug to take. Sometimes we give ourselves self-medication, which is not good. So you have a challenge and you don't know they don't know how to cure it. So they don't know what to do. So they will just tell you their problem. Example now, if they are trying to check if malaria infection has anything to do with dry season, dry or rainy season. So look at what they will do. They will collect data for dry season. During dry season, they will collect people that had malaria and people that didn't have malaria. During rainy season, they will still collect people that. So now they want to check now if the person will come. I'm looking at this. Is that weather season has anything to do with malaria? People contracting malaria. So they just tell you that this is what I'm trying to do. I'm trying to do a research, and I can't just make a claim without any scientific proof. So can you assist me to do that? You now look at it and laugh within you that this is a simple work, but the person will think that it's a big tax. You just know that what you use is chi-square test for association. The person may also come with it's like VC. VC is bias. VC is bias. VC is always giving grant to School of Engineering. Now, can you prove that this is bias? What the person is trying to tell you, have only one variable, and the variable is what? Faculty of the university. And now, in the faculty now, it has up to 6 or 7 levels. We have subs, we have SOET, we have SOT, we have SAT. So now you then check if the grant VC is given are evenly distributed or not. If they are not evenly distributed, it means there is biasness in the distribution of the grants. Do you understand? So the person will just come with a real life problem. So you'll be the one to recommend the appropriate statistical tool to use. So based on our what do they call this? Our course outline, we have done descriptive statistics, we've done data visualization, we've done chi-square test for equality, we've done chi-square test for association. So we have done 1 to 8. We are in number 9 now. remember, we have 15 topics to treat. It means we are going to even finish before the 4 weeks. So we are in number 9, linear regression. Okay, before we do number 9, we'll skip to number 13. We'll do number 13, number 14, and number 15 before we go back to number 9. So what we are going to treat now is t-test. But Emmanuel, I hope you understood the explanation I gave, the real life explanation, right?
Yes, sir. Yes, sir. Yes.
So when they bring problem to you, they won't tell you, they don't know what to do. And you don't make it, you have to package yourself. You don't make it look simple to them. You don't make it look simple, because if it's simple, they won't come to you. So you don't also make it simple to them. You package yourself and use them well.
Okay.
Okay. So now let's learn chi-square. T-test.